Today's lesson is called Difference of Squares. Now, let's answer the same question we answer almost every day. What are we doing today? We'll be recognizing the difference of squares and factoring them properly. How do we know we understand? Well, we can square root terms and create two different factors for every difference of squares. So, what you need to understand is that every difference of squares looks something like this: x squared minus y squared, or something like this: a squared minus b squared. Now, this is the key concept that we're looking at today. Key concept. Basically, a difference of squares has two parts, which are two terms, both of which are perfect squares. So let's identify what a perfect square is. So for a coefficient, suppose I had the number 25. We know that 25 can be written as 5 times 5, right? So this is what we call a perfect square. Now, another example could be, say, 4. 4 could be written as 2 times 2. Alright, now let's go and take a look at what a variable would look like if it was a perfect square. Let's say I had x squared. For a variable like this, we could write it as two terms, x times x. If I had x to the 4, I could write it as x squared times x squared. And both of these examples are considered perfect squares. I could also write y squared is equal to y times y. And there we have it. So each of these terms, that are just variables here, are just considered perfect squares. Now, if I had a term which was actually a mixture of a coefficient and a variable, an example of a perfect square for that would be, well, 4x squared. So what would you get? You'd get 2x times 2x. And the way we do this is, to get the 4 to turn into the 2, what we do is we take the square root of 4. And then for the x, we're literally just taking the square root of x squared, which is just like taking half of the number 2, which is on the exponent of x. So let's go through a basic example. Suppose I have the following equation: 4x squared minus 25. We need to be able to recognize that this is a perfect square. And the reason why it's a perfect square is because you'll notice we got a perfect square here and a perfect square here and a minus sign in between. So this is what we call a difference of squares. So the reason why it's called a difference of squares, there's a minus in between. Now, we're going to go through the algorithm to actually break down a difference of squares. So, in my head, I actually think about this. I actually say, okay, well, 4x squared can be written as, well, 2x times 2x. Now, and we also know that 25y squared can be written as 5y times 5y. So we know those are perfect squares based on what we talked about earlier. So we'll just check that off right away. Whoops! So we do know it's a perfect square, and because it has a minus sign in between them, guess what? This is a difference of squares. So we're going to apply the rest of my algorithm. So now what we're going to do is we're going to square root both the 4x squared and the 25y squared. So if you do that, you should have something looking like this. So our 4x squared becomes 2x. So just think of it this way. We actually square root the coefficient, but then we take the power of 2. When we square root x squared, we take the power of 2, we go x to the 2 divided by 2, which is just x to the power of 1, which is just that. But we don't normally write x to the 1. So now we're going to take a look at the second variable. The square root of 25y squared. Now we're going to apply the same rules as before, and we're going to get something that's equal to, 5y. Now, we use the terms in the first two terms as the first and last term in two sets of brackets. And then all we're going to do is we're going to put a plus sign in between it. So, basically, what we have is something that looks like this. We basically take our factors. So, this is what we start with, and then we break it down into two parts. 2x, and we take our 2x and we put it in the front of each part, because that's what we started with. And then what we're going to do is we're going to put in our 5y in both brackets. Then all we have to do is choose which one of these we're going to put our plus sign in. So I'm going to put my plus in my first bracket and my minus in my second. Now, just to prove that this works, all we have to do is expand it. So yes, we'll use distributive law. In doing so, we get something that looks like this, and you'll notice that the middle terms, when we add them together, will add up to 0, which actually just disappears. And we get the original equation. So, guess what? This problem is correct. And now let's move on to some practical problems so you see how you can do this in like literally 2 steps. Recognize is that x squared is a perfect square and 36 is a perfect square. So the moment we have that and we have a minus sign in between, we know it's a difference of squares. So we immediately break that down. So we have our 2 brackets. So because we have our 2 brackets, what we're going to have to do is we're going to have to take the square root of the first part, and we're going to have to make sure it's in both brackets, and then put the square root of the second part, put it in the next bracket. So the square root of the first part is x squared, so we square root it. We get x and x. We make sure that they start in the front. And then we also notice we have 36. The square root of 36 is 6. And basically all we have to do now is just put a plus and a minus, and that's it. Next problem, pause here. Here we go. So now we get equals, and we get square root of a squared is a, put it in the front, and then square root of 100 is 10. Now we'll put our plus sign and minus. Remember, we must have 1 plus and 1 minus, and that's it. And now we'll go through the rest of these. The next one we have 4b squared minus 81. Square root of 4 is 2. So let's put 2 in both brackets. The square root of b squared is b. So that's our first variable, 2b. And then Our second variable in the equation is 9, because the square root of 81 is 9. Put a plus, and then a minus. We do the same thing again. We recognize our difference of squares. We put our brackets. Square root of 16 is 4. X. And then the square root of 25y squared is 5y. We make sure it's in both brackets. And then we make sure there's a plus in one bracket and a minus in the next. For this next problem, you'll notice that we have two perfect squares in 9x squared and 64, but there's a plus sign in between. This can't be factored. Sometimes you might have a common factor, like what we see in the next problem, and you have to do that first. So the common factor between 27x squared and 75 is 3. So we put our bracket, and then we divide both of the terms by 3. We get 9x squared minus 25. And now we have our perfect square in the bracket. So when we have our perfect square in the brackets, we bring this down, and we produce two brackets for our factoring. So the square root of 9x squared is 3x, and we put 3x in the other bracket, and then we do the same for the second part, 25. So we got a 5 and a 5, and we must put a plus in one bracket and a minus in the other, and we are done. Your homework for today is page 28. Number 1, 2, ACE. So we'll do those, and I think you also have question number 8, ACEG as well. Good luck.